I'd like to take a few minutes to consider how evolution by natural selection might explain extreme traits like the giraffe's neck or the toucan's bill. Part of the problem here is we've sort of built a little model that looks something like this, where we take a trait that's distributed like this, and this might be the length of the bill, let's say. And we know that the average of the length of that bill, x bar, is going to be here in the middle, and some are going to have longer bills, and some individuals will have shorter bills. And this is the frequency of individuals over here. This is a population that has a variance, and we can see that variance here. And we also, if we assume that the bill is genetically controlled, then we know that when selection works in this system, and let's say that selection favors these individuals, and I'll call this the selection for the longer billed individuals, then what we expect to see is that in the next generation, as we come down here, these guys reproduce on the right side and the left side. We can put selection against over here, because if it's selection for one group, it's by default selection against the other. So the ones on the right reproduce, and they make a new distribution. Looks like this, slightly to the right of the previous one. Now I can put a dashed line in here so I can see where x bar 1 was, and then we've shifted now to x bar 2. So essentially in one generation we have moved to the right with our whole distribution. Now the question is, how does this explain something like the long bill of the toucan? And I want to look and try to understand, I guess the answer to this question is that if these are small steps, right? So let's say that these steps are really small. Let's say this distance is only 1 millimeter, which is really not a very long distance, I don't think, even for a toucan's bill, certainly not for a giraffe's neck. Then, in a population of several thousand individuals, that's not too hard to imagine. So the answer to the question is it just takes time. So in order for this slow process of evolution to work, we need to have long periods of time. But let's take a look. If the selected differential, and you better ask, I guess, what is this bill good for? Put that circle there. And having witnessed a few toucans in nature, I can tell you they use these things not only for plucking seeds off of plants, which they do, but they also use them for reaching into other birds' nests, like cavity nesters, and pulling out their eggs or babies and eating them. So toucans can be pretty aggressive hunters. Those bills are put to use for the slaughter of baby birds in my experience. So toucans can be pretty aggressive. So in any case, let's imagine that you could reach deeper into more nests and eat more young of other birds with a slightly longer bill, so you have this advantage. But let's ask what happens if you say that each generation can maybe have a change of 1 millimeter, has a 1 millimeter change in bill length. And let's assume that in birds it takes 3 years to have a generation. Let's even give them longer than that. Let's give them, I think 3 is plenty. So 3 years per generation. So in, let's say that in 30 years, we would have 10 generations, and that would be 10 millimeters of change. That would be really fast. Holy smoke, that's really, really fast. But in 300 years, we get 100 generations, and that's 100 millimeters of change. Now keep in mind, this is 1 centimeter. This is 10 centimeters. In 3,000 years, that's 1,000 generations. That gives us 1,000 millimeters of change. And 1,000 millimeters, now 100 centimeters, we're up to 1 meter, right? You can see where this is going, and in 30,000 years, what we have is 10,000 generations, which gives us 10,000 millimeters of change. which is equal to 10 meters of bill. Holy smoke, that's a little bit ridiculous. Couldn't even fit it on the page. But the idea is that given long periods of time, there is ample opportunity for evolution to develop these long traits. These large traits, probably what has happened is that over time, the bill is selected to be favored to a particular length, and at some point it gets so long that it's hard to fly with it. And so it's no longer an advantage. And so the selective regime might move on to favoring some other traits that are more important than bill length at that point.